Ransomware operates through a structured kill chain of attack stages, from initial access and lateral movement to data encryption and extortion, aiming to infiltrate systems, evade defenses, and disrupt operations for financial gain. And there are top 7 countermeasures to break the ransomware kill chain according to cybersecurity experts. Arcfra Enterprise Cloud Platform, AECP, can break the ransomware kill chain by combining prevention, microsegmentation and backup, detection and visibility, smart alerts and traffic visualization, containment, network isolation, policy-based quarantine, and fast, reliable recovery from backup or replication. In this video, we will introduce the integrated ransomware protection solution and showcase how it works with a demo. This is the integrated solution. When abnormal traffic is detected, AECP can send smart alerts to the operation team. You can quickly identify the affected VMs. Then, leveraging Arcfra network service, you can quarantine the affected VMs and contain the attack within your organization and minimize the security breach. Finally, you can restore the affected VMs from previous backup images by Arcfra backup and disaster recovery. When the VM is restored, you can unquarantine the VM so that your environment can recover to normal state. During the demo, we will simulate a 2-tier application which is attacked by ransomware, and then see how we can leverage Arcfra products to restore the application to normal state. The demo includes 4 parts. Part A is about the initial normal state. In this part, we will show the overall demo environment, the backup plan for the application, and the security policies associated. The application name My App consists of Web tier and DB tier, with 2 VMs in Web and 1 VM in DB. We will walk you through how the Arcfra distributed firewall works. There are several network security policies in place to secure the application. Specifically, a global policy to allow management traffic via port 22 for my client, 192.168.4.1. Web tier security policy can allow egress traffic only to DB tier via port 3306, ingress traffic limited to HTTP on port 80 and 443. The DB tier security policy only allows ingress traffic from web tier on port 3306. Additionally, there is a backup plan which will back up the whole application, 3 VMs, on a daily basis. Firstly, let's take a look at the demo environment. This is a 2-tier application, which has 2 tiers. One is the DB tier, the other is the web tier. You can see the information for each VM here. And next, let's move on to the backup and DR screen, where you can see the backup plan for this application. Basically, the backup plan covers all 3 VMs of this application. Next, let's check the backup schedule. You can see here that we back up this application every day with a full backup. We can also check the recovery points for a specific Web02 VM. There is one recovery point on October 7th, which we will use to restore this VM. Next, let's see how we can secure this application with Arcfra network security policies. First, let's check the network connectivity without any security policy deployed on this application. For Web02 VM, you can see it can ping both Web01 VM and the DB VM. And this VM can access the web service of Web01 via port 80 and MySQL DB service via port 3306. Similarly, for Web01 VM, it can access MySQL DB VM service and ping MySQL DB VM, Web02 VM, etc. Finally, let's verify MySQL DB VM connectivity, like ping web tier VMs. So, from MySQL DB you can ping the web tier VMs. Next, let's deploy security policies for this application and see how they affect the network connectivity. We have already composed 3 security policies for this application. Let's enable them now and observe what has changed for network connectivity. From the DB tier, ping to the web tier has been blocked. From Web 02, DB service is still accessible. Web service from Web 01 is also accessible. But ping to DB VM is blocked, while ping Web 01 is still okay. Similarly, let's do this check for Web 01. DB is accessible, but ping is blocked. And ping to Web 02 still works. Now let's take a close look at these security policies. The first is the database security policy, which allows ingress traffic only from the web tier and does not allow any egress traffic. Another policy is for the web tier, which allows egress only to the DB tier and only allows ingress traffic for web services. There's also a global security policy, which allows ingress for SSH access from my management client, which is 192.168.4.1. Let's double check. You can see that we can access the web services from my management client, but access to the database from my client is blocked. Ping requests to both the web tier and database tier are also blocked from my client. This result is by design, according to the predefined network security policies. Alright, that's part A for this demo, which shows the normal state of the environment before being affected by ransomware. In part B, we will simulate a ransomware incident on Web 02 VM, which will send massive network traffic to both Web 01 and MySQL DB. Thanks to the AECP Smart Alert feature, abnormal network traffic alerts will be triggered and shown in the Arcfra Operations Center. On receiving these alerts, we will jump in to investigate the abnormality. As we have deployed security policies in the environment, fortunately, we can only see abnormal network traffic from Web 02 to Web 01. Abnormal traffic from Web 02 to MySQL DB has been blocked by the distributed firewall provided by Arcfra Network Service. As a result, we can quickly identify the Web 02 VM as the affected VM in this incident. Let's see how the ransomware attack was detected. Firstly, we are alerted by 2 alerts in Arcfra Operations Center. These 2 alerts are about abnormal network traffic in Web 01 and Web 02 VMs. Let's dive into these VMs to see the network traffic pattern in the VM Monitoring tab. We can confirm the abnormal network traffic in these 2 VMs in the past few minutes. On the other hand, we can see the traffic of MySQL DB VM is pretty normal. Now let's switch to traffic visualization for more investigation. We can see small traffic from Web 02 to MySQL DB, which has been denied. More importantly, we can confirm that the traffic from Web 02 to Web 01 is significantly large in the last 30 minutes, and this traffic is secured. We can identify that the abnormal traffic is from Web 02 to Web 01 via port 80. Now, we're pretty sure that Web 02 has been attacked by ransomware. Part C is to showcase how Arcfra can contain the ransomware. As the affected VM has been identified, we will leverage Arcfra Network Service to quarantine this VM immediately, so that we can contain the attack and minimize the security breach. Now, let's see how it's done. As Web02 has been affected by ransomware, we need to quarantine it ASAP. Click the Web02 VM Network Security tab, then click Quarantine. Let's do forensic quarantine here, which allows my SSH management client to still access this VM. Now let's check the network connectivity for Web02. We can see access to Web01 and my SQLDB has been blocked. Hence, the Web02 VM has been quarantined, and ransomware has been contained as well. That's part C for ransomware containment. In this final part, we will restore web from a previous backup. After the restoration, we will investigate the network traffic again to make sure the ransomware has been removed. Then we can safely unquarantine Web02 so that it can recover to normal state. Since Web02 has been quarantined and the security breach has been contained, let's go to the last part to recover the affected VM. Firstly, we need to restore the Web02 VM from the previous point. Locate the right VM and restore point, then click Restore. Then we can check the progress in the task window. The restoration process will take a few minutes. During this process, the old VM will be powered off and a new VM will be started with the restore point data. When restoration is completed, we can see the new VM is running. We can do a sanity check of this newly created VM for network traffic. We can see that there is no longer any massive traffic from Web02 to Web01. Similarly, let's double-check the Web01 network traffic as well. We can verify that there is no massive traffic from Web02 anymore. The last step is to check the network traffic of my SQLDB. We can confirm that there is no abnormal traffic as well. Since all network traffic has been back to normal and the affected VM has been restored, we can unquarantine Web02 VM now. Go to VM's Network Security tab and click Stop Quarantine. Now we can check the network connectivity again to see if the network has been restored to normal state. From the Web02 VM, let's ping Web01 and access the DB service from my SQLDB. All works well now. Awesome! Now the Web02 VM has been fully recovered to normal state from the ransomware attack. And that wraps up our comprehensive demo. We've just seen firsthand how Arcfra can break the ransomware kill chain efficiently. Thank you for watching. We hope this demo was helpful and informative. You can explore more about Arcfra products on our website and social media.